The first use case I'm excited to talk about is automating public cloud, or really infrastructure as a service with Gluware. We've shown other demos in the past of automating the network as we're enabling the network and traffic to move to the cloud or in and out of the cloud. Now we're actually talking about automating the network that exists in the cloud. So, and as I was talking about, as network operations engineers, we spent years becoming experts in Cisco and other vendors, and now we're being asked to learn cloud infrastructure. And it's a lot of the same concepts with, routing and load balancing, other things, but it's a different language and it's different constructs. So how can we help them do that? Well, back in 2016 or so, we started automating clouds via their native API. But what we found is that, you could do individual things, but boy, if you want to automate a full-blown VPC provisioning in a complex pod in one of these clouds, it was going to be a really big investment and a lot of complexity in interfacing with that API. So what came along is something many of us know now. It's called Terraform. Terraform provides an infrastructure as code approach and has built the adapter to work with their various providers, which happen to be some of the most used providers are the public clouds. So what Gluware has been able to do is we integrated the Terraform engine as like a vendor adapter within our system, and then we're able to leverage various plugins that Terraform supports. So what we're going to show you is the ability to kind of bring your own design or bring your own policy, and you can do that through what you want to deploy in the network. You also can import Terraform files, the HashiCorp config files, you can import directly into Gluware, and how Gluware can help you automate down to the clouds. So with that, this is the use case. And what I want to highlight here is that this is actually very similar to several engagements we've been in, where they're not doing trivial automation, like automate a simple VPC. They have these fairly complex designs, and they want to be able to spin them up when they're needed, tear them down when they don't. In this particular one, it's multiple VPCs. You have the transit gateway component, you have internet gateway, and then you have all the rules that go into the transit gateway that enable the various configuration. So what you're going to see in the demo is Gluware kind of creating the Terraform file and the components that you want automated, and leveraging Terraform to initiate the API calls to provision that within AWS. So I'm going to now stop sharing and enable Olivier to take over and show the demo.
I have a quick question.
Sure.
Is this available for all three clouds or just for AWS currently?
So Rita, to answer your questions, we can onboard any provider that we see fit. Right now, we started with 3. Okay. And we're contemplating others, either written by HashiCorp themselves or some vendor-supported ones. Technically speaking, we could adopt community ones as well, but it's a matter of bringing something that has support, that has a lot of testing behind. That makes sense. All right. Okay. So I'm going to show you what Mike was showing in the slide, which is a pretty common use case that customers are asking for. And if you allow me, I'm going to start the provisioning right now because it takes 9 minutes to build. And then I'll explain what I'm doing. So I'm starting our engine with this big model. I'm going back to explain what this is. This is my AWS console that you can see has loads of zeros here. And basically what we're building, I have a different drawing here, which is the IP addressing is different, but this is the same principle where the idea is you have VPCs and you want to control the flow of data through these VPCs, with TGW in the transit gateway, and you want to hook up VPN services and make sure that you have this cheat sheet here, honoring all the rules that you want to enable in this thing. So here you can see our engine started. I'm going to show you this Terraform configuration, the theoretical configuration that is here. So you can see it's pretty rich. There's a lot of aspect in this, right? And there's like 750 lines of Terraform config here. And so what the engine is doing right now is deploying this particular configuration that you see here, visually represented. And this is the same CLI config modeling that we apply to all the vendors that we support, but apply to Terraform. And you can see that while this is happening here, the way you contemplate a configuration within config modeling is that you can consume them into reusable blocks, right? So here I'm showing you a VPC. I'm creating like simple VPCs. I got 4 here. And you can see that this is the configuration broken down. And I've got all the different aspects of my configuration here that I have used, that I have put in my model here. The idea behind this is twofold. The first aspect is you want to make sure that you can have reusable blocks. Let's say that this is a typical pod that you want to deploy, and maybe this VPC setup, like 4 VPCs and with TGW in between, maybe this is something you want to deploy 100 times. So the idea is to be able to make this whole thing reusable and, most importantly, dynamic. You can see that in this particular example, right? I have a fixed IP block here. What if you would want to contemplate this dynamically? So the way we do this, let me show you a different node here, which is something much easier to understand. Look at this block of CLI here, and this block of CLI, you can see I have this particular model of for a VPC, and I'm feeding this with a data model where in this particular aspect here, this is what I would like to entertain. It's like 5 VPCs, and this is what I want to do. It's like I don't want to have to type this different VPCs like over and over and over, and every single iteration I have to create a new one. So I can show you a preview, because yes, we can preview, allows you to figure out what's going to happen as opposed to just discovering what's going to be the end result that you might not want. So the idea is that when you have all these different blocks generated, then you can reuse them at will. So I'm showing you that I have a data model with a form with user interaction. But what if you want to do this where you want to integrate with a CI/CD pipeline? What if you want your system to inject this into Gluware? What if you want Gluware to go fetch that data because it's in an IPAM system, because it's in a REST API endpoint where you want to go grab this whole thing, right? So let me show you the preview here that was generated. You can see that I have my, all my 5, 4, 5, I'm not sure how many I put there, VPCs that are here, right? And these are the VPCs that will be generated in the configuration that, Terraform will ingest, where I entertain only this particular configuration. So if we go back now to the other bigger provisioning, let's see where it's at. Go in the logs here. So this is happening. I told you it takes roughly 7-8 minutes to do that. So it is happening. If I show you the progress, remember this is my my view on my VPC account, and if I refresh, you can see some values start to appear. In the meantime, I can show you that you have 2 ways to contemplate a Terraform configuration. I have another smaller configuration for Terraform here, and you can see that same principle that I use for the big configuration. You have like single items here. This is my routes table that I have here, and you can see that in here we have all the different things that you can choose from. All the different resources, data sources that you can use from the provider, from the AWS Terraform provider. But maybe this is not the choice that you would like to see this config. You're used to have this big configuration. I can show you here. I have another view for it, which is this one, which is the exact same configuration, but you want to have this with mixed resources, right? You see I've chosen mixed as opposed to single items. And you can still continue to operate it this way, right? Oops, I don't want to change that. And of course, you can make this dynamic like I showed earlier. The point here, what I'm showing, is that you can still keep the way that you're comfortable with to manipulate these different configurations. You can also choose to have the configs in Gluware, or you can go and fetch them from a whatever repo that you have. This is another way that you can entertain as well. Now, if we go back to our provisioning, our big provisioning, let's see where it's at right now. And it's finished, right? So if you refresh here, you can see that I have, where's my TGW? I have my TGW here that has been generated. And I have the most critical part of it, which is the way that I want to entertain, my propagations, my routes here, to make sure that I do observe the cheat sheet that I've shown you earlier.
Yeah. So one of the goals that you guys stated for Gluware is that you're trying to distill down programming knowledge for people to be able to use automation. So if I take something like Terraform, in the example you gave, how much knowledge of Terraform, if I take a junior engineer that isn't familiar with Terraform, can they generate all of that config by walking through the templates that you have? Or do you have to have somebody that has some basic knowledge of Terraform to set those modules up for them? How far does that abstraction go?
So today, you have to have your configurations. However, the engine, and in fact, I can show you that, the engine is able to help you consume this configuration, because I can import an existing configuration, right? I can import, and I can import a configuration. Either I want to copy paste, or I want to use an existing instance of this. And the engine will understand the configuration and helps you to break it down into all these different blocks. So today, you do have to bring your own Terraform configuration. However, because the engine has understanding of all these different variables here, all the different resources and data sources, we're coming up with this notion of templates that allow you to have kind of a generic empty VPC, in the case what I'm showing you here, which allow you to have the kind of the default CLI pastes, and then you can just put your settings in it, if that makes sense.
Gotcha. Yeah, that makes sense. And then a follow-up question is, from a security standpoint, as far as securing Gluware, how do you, if I want to turn over a task to a junior engineer to repeat and say I'm going to take this template and repeat it, how do I keep them from running up an $80,000 AWS bill? What kind of controls are there to mitigate that?
So let me repeat the question, make sure I understand. You're asking, how much code reusability you have, or from a pure aspect, you don't want anyone to touch this particular service that you have, deployed, and you want to make sure that, they don't interact with one another.
Or let's say, for example, that I intend that this may get reused, something I want to spin up gets reused 10 times or 20 times. What if it gets deployed 2,000 times? How do you control that process?
So we've got RBAC built into the portal. We can make sure that we use also multi-tenancy and all this. We've got hierarchical orgs, so you can definitely have a parent organization that oversees everything, and give your users certain sub orgs that will only include the instances that you're allowed to touch. So we have this notion here, this node here, the AWS Cloud Service that I've used. You can create as many as you wish of this. You have reusable items like the assembly, which allow you to have the same sets of Terraform phases that you might have. But the node is a way to create as many as you wish, and I can permit you to only touch yours, and someone else cannot touch your nodes, if that makes sense.
Gotcha.
Do you guys have any plans to go the other direction? In other words, allow your system to generate the HCL for Terraform? Or is that just not anything that you've thought about?
Yes, Terrence, a great question. So yes, that's the plan. So we are able to ingest the configuration from today. We have something called intelligent model discovery that we use for existing vendors. And the idea is you take the monolithic configuration, like a Cisco configuration, and then we understand the cost part of it, the encryption part of it, the routing part of it, etc. So we're trying to apply, this is currently, in engineering right now, we're trying to leverage the Terraform Import capability to be able to ingest a configuration on an AWS VPC, for instance, and try to generate the resources and the resources that was used. Yes, that's the plan. Because the idea is that if a customer's got a Terraform deployment, he's just using his own way, using CLI, etc., or whatever system he's using, and he wants to use Gluware, we're going to be able to import all these existing configurations. But what if you have a customer that has already deployed all their AWS infrastructure and has not used Terraform? So the idea is to be able to offer kind of a, let me say it this way, like kind of a brownfield for Terraform. And of course it's not perfect because there's a lot of intent that's lost, right? So the idea is to propose a kind of a candidate, configuration, and you've got enough of a base to start, and maybe you're going to, apply your different tweaks to that, if that makes sense.
I'm trying to understand the value of using Terraform in Gluware versus using Terraform natively. So, I mean, I see that I can pull in, existing Terraform scripts. You kind of parse them out into, I guess, more consumable sections, but I don't see any additional value. Like, what's the reason to do it in Gluware rather than doing it natively in Terraform? Or is this like the first step in a multi-step process? So we're just seeing something very, very early, and the idea is to go later. Because what I see here, you have a long history in modeling networks. And if you could bridge that Terraform into the rest of your modeled network, that would be fantastic. But I'm not seeing that here.
So, Jordan, this is a great question. You usually don't have just AWS. You also have an existing infrastructure. So what if you want to automate your, branches that have, I don't know, like physical devices, and then the rest of it is in Amazon, right? Is on AWS. Then with Gluware, you can build models where you can entertain like your IPAM system being able to feed the two systems at the same time, and you want to make sure that you've got consistency. You're not managing two different things, my branches and my AWS. You might be like to create a data model, because this is something we're not highlighting here. We covered that into previous videos, but our data modeling capability allow you to build a view of your network where you can see into under one model both your branches or your data centers or whatever, and AWS or wherever you're hosting your network. So the idea is not to have two separate items and then someone's going to have to bridge, the two to make sure that they talk with one another, that they share the same subnet or same ASN or same whatever that is. So the idea is that if you bring this under the same view, then you holistically manage your network, not just two different systems, if that makes sense.